Let's go ahead and look at another calculation that we can do with circles. So we already covered the area of a circle, circumference, and arc length. So the area of a sector, it's a portion of the area of the entire circle. So let's go ahead and illustrate what that would look like. So let's go ahead and approximate the center of the circles, which I'm going to call P. We're going to go ahead and draw two radius, and I'm going to call the endpoints 1A and the other one I'm going to call it B. So what I'm shading here would be part of the circle, right? So we call that a sector. So our goal is to find out what that area of the shaded region is, which is a sector of the entire circle. So we're going to use this formula here. So we're going to use A for area, and then since we're not taking the area of the entire circle, we're just going to put sector. So for the entire circle, to find the area, we do pi r squared. We're going to implement that in our formula to finding the area of a sector. All right, so since we only want a portion, we're going to take the portion out of the whole 360, which is the measurement of the entire angle. So we want to know how much of the entire circle we have, which will be whatever the measurement of the central angle is. So the measurement of the arc, which is that section that we're trying to find the area for, we'll take that out of the 360. So that gives you the formula for finding the area of a sector. All right, let's go ahead and look at a problem then. So on here, we have two different sectors on the circle. We have the blue sector and we have the red sector. So we're going to go ahead and start with the red one, since it's the smaller one. So we apply our formula here. This is what it would look like. So we want a portion of the circle, and we'll take it from the area of the entire circle, which is pi radius square. All right, so on here, on my circle here, let's go ahead and identify what the radius is, which is 14 feet. And the measurement of that central angle is the measurement of that arc. So the measurement of that arc that I highlighted in green would be 120 degrees. So out of the 360, I only want 120 degrees. Let's go ahead and replace the R with 14, and we'll square our radius. The rest is just simple calculations. So I usually leave my fraction alone. Then I take care of my squaring, which is 14 times 14. That gives us 196. And then I'll put it over 1 since we're multiplying a fraction by that whole number. So fractions, we multiply them straight across. So I'm going to go ahead and multiply 120 times 196, and that would give us that much. Then all over 360. Now, if the problem was asking for the exact answer, that would be it. The only thing that you would have to do is reduce that fraction. So I'm going to go ahead and give you a couple of seconds here and see if you guys can try reducing that fraction. All right, and in the problem, it didn't really specify if we needed the exact answer or not. So I'm just going to go ahead and round this up. So I'm going to go ahead and do 23,520 times pi, and then I'm going to divide that by 360, and that would give me approximately 205.25 if I round to the nearest hundreds square feet since it's area. So the area of that portion of the circle that was shaded in red would be that much. And then we're just going to simply apply the same process for the other part of the circle, which is shaded in blue. I need to know what the length of that circle is. Sorry, the length of that arc, which is FGE. I know it's going to be more than 180 because it's a major arc, since it will measure more than 180 degrees. It's more than half of the circle, and half of the circle is 180. So if the whole thing is 360, I subtract that part that was part of the red sector, then that would give you what the measurement of arc FGE would be, which we get that is 240 degrees. All right, let's go ahead and set it up the same. And I'll follow the same process. So I'll square my radius first, leave the fraction alone for now, reduce if I was looking for the exact answer, or give an estimate if it didn't tell me to give this exact answer. We'll put a whole number over 1, and then we'll multiply our fractions straight across. So some of these calculations here, when your radius, it's a high number, you can say, can get a little tedious. So if you wanted to avoid reducing at the very end, you can always reduce your fraction in the beginning. So you can reduce the 240 over 360 and at the very beginning, and that would lead us to something way smaller to reduce at the end. But again, it didn't ask for exact answers, so I'm just going to go ahead and multiply the 47,040 times pi, and then divide that by 360, and that would give me 410 square feet. Which makes sense, right? If the blue sector is bigger, it should have a larger area than the blue sector, than the red sector.